Okay, so topic 3 and how to use your calculator. A whole bunch of these early ones. So 3.1 looks at distances between 2 points. I'm pretty sure the formula is on your formula sheet in three-dimensional space. You might remember doing that. Volume and surface area of three-dimensional solids, size of an angle between two intersecting lines. All of this you will use your calculator for, but I'm not going to spend time looking at it now because effectively the calculator usage is just like a scientific calculator. It's just plugging in numbers and working stuff out. Similarly with 3.2 and 3.3 and 3.4 and 3.5. Oh, no, not 3.5 and 3.4. All of these you could use your scientific calculator for or your graphics display calculator for. With just a reminder that my suggestion is that you have your calculator in radians for your GDC and you have your scientific calculator in degrees. So you're just switching between calculators. And just because this is the trigonometry part of the unit, let me just remind you that students tend to ask, when do I use degrees and when do I use radians? How do I know that a function is in degrees or in radians? Number one, the domain will give it away, potentially. Number two, if the domain does not give it away, assume radians. Degrees has a unit, the little circle. Radians is unitless. So if you've got a Ferris wheel problem and it just says 2 pi x, sine of 2 pi x, something like that, or sine of 3x even, you can assume it's in radians. You have to, okay, because radians are unitless. Alrighty, so with that in mind, very briefly to remind you, very briefly, there's your trig functions there. If you're trying to work out sine, cos, and tan, then you're using these ones. If you're trying to work out the angle, it's sine, inverse, cos, inverse, and tan, inverse. These three for angle, these three for the functions themselves, which output a value. Actually, there was one little thing. No, that's later on. That's okay. That's on a different part of the topic. So let's have a look at 3.5. 3.5 is where it starts to sort of kick off in terms of basic understanding of stuff. But I wanted to just talk very briefly about trigonometric ratios or equations where you've been given a value and you have to work out the different values of sine. Fundamentally, guys, in a non-calculator section, the idea is to manipulate the trigonometry function, whatever you're given, so that it's equal to a value that you know is one of those exact values you're supposed to understand. So if I have 2 sine 3x, again, sorry for the video for it just being board work. If I have 2 sine 3x, is equal to negative root 3, if that's the equation that you're given, then your job in a non-calculator section is to go, I need to make this into trig function equals value. So if I divide both sides by sine, I get sine 3x is equal to negative root 3 on 2. Okay? So that's basically what you're doing. And then you're going, well, root 3 on 2 is one of the values that I know. Either because you've memorized it, because you can picture a table in your head, or because you can use the trick of drawing out half an equilateral triangle. And then you know that for sine, the sine is opposite over hypotenuse, so that'd be root 3, is opposite over hypotenuse, so it's root 3 on 2. So therefore you know that the sine of theta hat equals root 3 on 2 means that theta hat is equal to pi on 3. And then you can solve it. Now that's beyond the calculator usage here, but I just want to say that's the approach you'd use, right? Excuse me. And we're going to use a domain of between 0 and 2 pi.